In this video, we'll discuss about composite functions. Now, whenever we talk about this composite function, composite functions. See, composite functions, basically what we are looking at is that in case you have two functions, alright, so two functions like one inside the other, they are basically composite functions. Fine. Now, let me give you an example for this and then we can do this one. Suppose say we're going to have, see, let's assume that you have one set here. All right. So in this set, let's say we have values such as say 1, 2, 3, and 4. All right. Now after this value is, let's say, set A. Set A has 1, 2, 3, 4. Now after this, what we do from here, we go to the another one. And let's say we have one more here. Okay, we'll come to the third part later. See, this is set B. Fine. Now from set A to set B, say we have a function. Now I'll define this as f. Now f is from A to B, which defines as f of x is equal to x square. So what will you get here? You'll get 1, 4, 9, 16. Correct? 1, 4, 9, 16 because f of x is x square. Now what we'll do, so we'll take one more here. So now this particular function, we'll name it in a different way. Let's say this is set C. Now, next thing what I'm doing is from B to C, say I define a function G. So how do we do it? G is from B to C such that G of whatever value we have, G of X you can call it, G of Y you can call it, whatever. Since we are already using f of x, let me give it another variable. Say we have f of y is equal to y square. Assume. Okay, we have y square. That means again we are going to square it. So you get 1, 16, 81, 256. Isn't it? So we have x square, basically squaring of the terms. This is what we have. Now what composite function tells us is that we have two functions f of x and g of x, or in this case we are just changing the variable. Composite meaning a function inside another function. So here what we do is we are going to take from A to C directly. A to C directly. What is your first function? First function is f of x, isn't it? So first is f of x. Now this function g, what you have, this includes the f of x function, isn't it? So g of x or g of y includes f of x. So what we write is, we write the g value outside. In the sense, here we'll write, so here in this case, it's going to be g of f of x. So this g of f of x, we call this as g o f. So g o f, that is g of f or f of x. So g of f of x. Now this is basically a composite function because one function is inside the another function. It's a composite function. And how are we defining it? We are defining it from A to C, isn't it? So how we write the composite function? It would be written like this. G O F from A to C, isn't it? We are going from A to C. G O F from A to C. So G O F is equal to G of f of x. This is basically the composite function. So G O F, G of f of x, correct? So f is inside, g is outside. Now there is one more way of, one more composite function. That is, if you write fog, never pronounce it as fog and goff. That's not a correct way of pronouncing this one. So it's always GOF. That's basically G of f of x. And when you say FOG, f of g of x. So this becomes f of g of x. This is the another composite function. So we have two composite functions. One is GOF, another one is FOG. So g of f of x, f of g of x. Clear? So this is basically what we call as composite functions. In the next video, we'll see one or two examples as to what it is. Understood? So then you will understand how do we write the function, what is the domain, range, everything for these composite functions.